Hey guys, welcome back to Jyoti classes, and today we will be going to the second part of mathematical physics, and today we are going to start with the numerical integration. Okay, in numerical integration or numerical techniques, I can say these are the different forms of methods. With the help of these methods, we can find the values for any of them. Using those functions, what is the value for that given function, we can find out. Okay, now next let us start this. Okay, so since we are aware of different types of numerical techniques, in which first one is bisection method, and then Newton-Raphson method, then trapezoidal rule, Simpson 1 by 3rd rule, and Simpson 3 by 8 rule, and next Newton forward interpolation formula, Newton's backward interpolation formula, Lagrange interpolation formula, Runge-Kutta method of second order, and Runge-Kutta method for fourth order. Okay, let us learn this much for today, and remaining part will be whatever is there in our for syllabus, we will be going through those points only. Okay, so let's start with bisection method. In bisection method, what we have to do is, we know that for us the function will be already given. Okay, function will be already mentioned in the given question. They will be given something like f of x. For this we have, this is our y, and f of x will be having some value, say x square or something like that. You have to find the corresponding y values. What are those values you need to find? What is the procedure to find this bisection method? First step is, for the given function f of x, you have to find the values for f is equal to 0, for f is equal to 1, for f is equal to 2. Any number you can do it. So I have taken 0, 1, 2. Let's take, for me f is equal to 0, I have got some negative value, and for f is equal to 1, some negative value, for f is equal to 2, some positive value. Okay, so for this will be the value, our root will be lying between the value of 1 and 2. Okay, so after that what we have to do is 1 plus 2 divided by 2, that is equal to 3 by, that is 3 by 2, that is 1.5. So our value will be 1.5. This is the initial value. Okay, x 1.5 is the initial value for the given function. Okay, this is the way. And again what you have to do is, just continue further, put the value for 1.5 for the function 1.5, you will get some value. Okay, that value may be positive. Then if this value is positive, then again, which was the negative value we had negative value for 1, right? Then now the next root, this was the x naught. Okay, this was the first one, and the next root, that is x1, is, this is the positive value and this is the negative value. Then 1.5 plus 1 by 2, then find what is the value. So depending upon that, take the corresponding x and y values. Okay, x and y value I can't say, take the value of, for the function, a and b value. Okay, it should be greater than 0 and less than 0 condition it should follow. Okay, this much for bisection method. Now you may not get clearly, but while solving the questions you can better understand. Just remember in simple way that you have to take the negative and the positive values and find the values, and using that value, finding the value for that function, using that we have to carry on further, further determining the values. Okay, next coming back to, see, now coming back to Newton-Raphson method. For Newton-Raphson method, first the function f of x is equal to 0, condition will be given from f of a is greater than 0, f of b is less than 0, and what is the formula for Newton-Raphson method? X of n plus 1, that is equal to xn the value will be that is xn plus 1 is equal to xn minus of f of xn divided by f dash of xn. Okay, you need to find the f dash function for the given function in your question. First thing, so here n plus 1 value represents what? So if I going to find the value for n is equal to 0, for n is equal to 0, then x of 1 is equal to what? X naught minus of f dash f of x naught divided by f dash of x naught. Okay, this is the value which you are going to get and solve it further. Just remember the formula for Newton-Raphson method. For Newton-Raphson method, the formula is more important. Okay, next, coming back to trapezoidal rule. For trapezoidal rule, the function is given from integration x naught to xn, or I can say integration from a to b f of x dx. Okay, for this, what is the formula for trapezoidal rule? The formula for trapezoidal rule is h by 2. What is h? H is nothing but width. What is the width of the interval? See, in your question, some tabular column will be given. They will be given your corresponding values like x value and f of x values. Okay, if it is 0, 1, 2 or something like a, b, c are the values, your width, that is your h. H is equal to what? From difference between 0 to 1, what is that value? 1 is your value. Okay, otherwise I can say that you can better remember like this: integration from a to b and some function f of x, the value of h is equal to already given limit b minus a by n. Like, what is the difference? How many number of columns you can create, or number of equal sub intervals you can create from that. Okay, this is the value to find the h. Okay, next, coming back to Simpson 1 by 3rd rule. For Simpson 1 by 3rd rule, n should be even values. Okay, then formula is then what was the formula for trapezoidal rule? That was h by 2 y naught plus yn 2 times the y1 plus y2 plus remaining up to yn minus 1. Now, for Simpson 1 by 3rd rule, the value of n should be even, and the formula is I is equal to h by 3 y naught plus yn plus 4 times of odd multiples, like odd numbers, and 2 times the even numbers. Okay, these are the odd numbers like 1, 3, 5 up to n, 2 times the even 2, 4, 6, 8. Okay, this is the way to remember that. This is the formula for Simpson 1 by 3rd rule. And next, for 3 by 8, same, you have to find the h value, and here the value of n will be multiple of 3, that is n is equal to 3. For Simpson 1 by 3rd, the n value is 2. For trapezoidal, the n value is 1. Like here, n value is nothing but the interval. Okay, the sub intervals which you create there. Okay, next, so formula is 3h by 8 y naught plus yn plus 3 times 1, 2, 4 and 2 times the multiples of 3. Okay, these are the multiples of 3 and this is the formula. Just go through the formula clearly. Okay, next, coming back to Newton forward interpolation formula and Newton's backward interpolation formula. Here, just remember the formula. For Newton forward interpolation, we take the values for y naught, and y naught is for forward difference is carried out of y naught. That is, the formula for that is y naught plus p delta y naught plus p minus 1 delta square y naught, so on up to delta n y naught. What is the value of p? P value is x minus x naught by h. H, we know that interval size, x which value we have to find, and x naught is the initial value. Okay, which is the initial value, and when you substitute this value, you will get p as the real number. Okay, This is Newton forward interpolation formula, and similarly for Newton backward interpolation formula, it is contains n and it is backwarded difference by yn. When you construct the table for that, you can better understand. But now remember the formula. Formula for Newton backward interpolation formula is C. Newton's backward interpolation of delta yn plus here p into p minus 1. But now here it is p into p plus 1. Okay, just this one. Sorry, I have written here p minus 1. It is not minus 1. It is p into p plus 1, p plus 2 by 3 factorial. Okay, correct this. This is plus. Okay, this is the backward formula, and the value of p is x naught into x naught minus xn by h. This is the value of p. Next, coming back to Lagrange interpolation formula. For Lagrange interpolation formula, simplest way to remember. See, here you are doing for x naught, here you are doing for x1, and here you are doing for x2. If you are writing for the first term, you have to take that x naught in the denominator and excluding, or I can say leaving x naught in the numerator. See, for x minus x1 I have left x naught. Okay, similarly now coming back to this one. See this, for this here x1 is the second term. For the second term I have started with x naught, x1 I have left here, x2, x3. But in the bottom we are writing for x1 minus of x naught, x1 minus of x2. Similarly so on up to you can write it for Lagrange interpolation formula. Okay, next coming back to Runge-Kutta method of second order. For second order Runge-Kutta method, first the ordinary differential equation will be given. For the initial condition for x naught, the value will be y naught. We need to find for y of x1. Here you need to find the k1 value, k2 value, then you will get the final equation as this one. That is yn plus 1 is equal to yn plus half k1 plus k2. This is for second order, so we are finding the two values of k1 and k2. Now for the fourth order, you need to find for k1, k2, k3 and k4 values. Okay. See, this is the for fourth order. Given function is given, initial conditions are given, we need to find for y of x1. For successively we need to calculate k1, k2, k3, k4. This is the respective formula for k1, k2, k3 and k4, and this is the value, final value which you have to do. That is y is equal to n plus 1 is equal to yn plus k. Okay, these many formulas for today's class. So your work, what is your work to do is just write all those formulas. Okay, here formulas are very important. So with the help of formula you can solve directly. Okay, many questions are asked, like repeatedly they are asked the questions on these methods. So what you have to do is do this much, and tomorrow's class we will be taking all the problems which are asked based on these these numerical technique questions. Okay, so thank you.